Myth: space just gets cold and quiet the farther you go. Truth: it gets louder in all the worst invisible ways. Beyond our blue sky are radiation belts and solar storms, giant charged particle traffic jams driven by the sun. Solar energetic particles can hammer a spacecraft in minutes. And then there's the silent killer: galactic cosmic rays, ultra-high energy particles from distant supernovae. They keep needling through metal, through electronics, and, yeah, through astronauts. On Earth we barely notice because our magnetosphere is a force field made by the planet's molten core. It guides most charged particles away, and it funnels some to the poles as auroras. But a spacecraft? It's basically a soda can in a hailstorm. No big magnetic umbrella. So engineers asked, could we build one? The physics says charged particles curve in magnetic fields. Make a field around a ship, and you can bend dangerous particles off course. That led to wild proposals: plasma bubbles, and mini magnetospheres. Inject a little gas, energize it, and let a magnetic cocoon grow bigger than the hardware making it. Lab tests and small experiments suggested it's possible to deflect particles. But early concepts hit a wall. Fields strong enough to matter needed huge magnets, huge power, and huge mass. Here's the plot twist. Superconductors leveled up. High-temperature superconductors, think Rebisio tapes. They can run megaamps with minimal loss when cooled, making compact coils with serious magnetic muscle. We're talking multi-Tesla fields from lighter, tighter packages. Pair that with smart coil geometry, toroids, and cusp fields. And you can shape the field to wrap a habitat. Add a small puff of plasma, and you inflate the protective region, boosting standoff distance so fewer particles ever see the ship. Why this matters beyond Earth orbit. Mars missions mean months outside our magnetosphere. Through solar cycles where storms can spike radiation dramatically. Passive shielding like water, or polyethylene. But mass adds up. Every kilogram steals payload from life support or science. Active magnetic shields promise adjustable protection. Dial it up during a solar event. Scale it down to save power during quiet space weather. Look farther. Interstellar probes. And long-duration habitats. They could combine magnetic shielding with smart storm shelters and operational timing. The goal isn't zero radiation, that's unrealistic with cosmic rays, but cutting dose to safer levels while keeping missions feasible. If this scales, it changes the playbook. Longer stays on the moon with lighter landers. Mars transits with crew risk managed in real time. Shielded transfer vehicles acting like spacefaring buses between worlds. That's the myth to truth arc. Space isn't empty, it's energized. And the next generation of superconducting magnetic shields could turn invisible threats into engineering problems we can solve. Safer crews, smarter ships, a future where going farther doesn't mean rolling the dice.